Here is another engaging problem designed to put your logical thinking and creativity to work and sharpen and strengthen them along the way. Hey everyone, welcome to Geomathic. The problem gives us a circle with a triangle inscribed in it, meaning all three vertices lie on the circle. The side lengths of the triangle are given. AB equals 13, AC equals 15, and BC is 14. We are asked to find the radius of the circle. So what's the first thing that comes to your mind? For me, the easiest way is to drop a perpendicular from point A straight down to side BC. Let's do that. Let's name this H and this point as D. The length of side BC is 14. The perpendicular we just drew divides it into two segments. If we call the shorter segment X, the longer segment will be 14 minus X. The next step is to use Pythagorean theorem to set up two equations based on H for triangles ABD and ACD. So for triangle ABD, which has a hypotenuse of 13, here we have 13 squared equals x squared plus h squared. So I write that for triangle ABD. We have 13 squared equals x squared plus h squared. Okay, therefore h squared equals 169 minus x squared. If I move h squared to other side, it gives us this equation: h squared equals 169 minus x squared. We need it later. And then for triangle ACD with a hypotenuse of 15, we have 15 squared equals the square of 40 minus x plus h squared. So I write that ACD. (15 squared equals the square of 14 minus x plus h squared. Okay, applying the identity, we have 225 equals 14 squared minus 28 times x plus x squared plus h squared. So h squared equals 29 plus 28 times x minus x squared. At this point we have two equations in terms of x, and both are equal to h squared. Therefore we can set them equal to each other and solve for x. So this equation is equal to this equation: 169 minus x squared equals 29 plus 28 times x minus x squared. The minus x squared on both sides cancel out. Then we have 140 equals 28 times x. So x equals 140 over 28, which is equal to 5. Okay, so x equals 5. Now that we have the value of x, which is 5, we can substitute it into one of aerial equations and determine h. I will go with the first one, this. So h squared equals 169 minus x squared, that is 5, minus 25, then h equals the square root of 144, which is equal to 12. Okay, so h equals 12. Now we have found the height, but the question asks for the radius of the circle. So our work isn't over yet. We know that the radius is half the diameter. So if we can find the diameter, we will get the radius. That's why I'm going to draw a straight line from point A, assuming it passes through the center. Okay, this is the considered center, so I draw the line and I name this point as E. If it passes through the center of the circle, this line is the diameter. Again, I draw a straight line from the point A, assuming it passes through the center of the circle. This line is the diameter and meet the circumference of the circle again on the other side. And now I want to connect this point E to point C, like this. It may look like we have reached an impasse, but actually it's not. If you look carefully, angle ACE subtends the diameter, okay? And the arc corresponding to the diameter is 180. And since ACE is an inscribed angle, so it's equal to half of that, which means 90 degrees. So based on the circle's rule, this angle should be 90 degrees. Now we have 190 degrees here and one here. Let me prove that these two angles are the same, here and here. As I just mentioned, when an angle is inscribed in a circle with its vertex on the circumference, like this too, its measure is half of the arc opposite it. And as you can see, both of the angles B and E lie on the circles and subtend the same arc, which is arc AC. Therefore, the two angles are equal. So I label them alpha and alpha. I'm sure many of you already guessed what's going to happen. Take a look at these two triangles, ABD and ACE. Now both of them share two angles. One is the 90-degree angle here and here, and the other is the angle we call alpha, here and here. So these triangles are similar by the AA, or angle similarity criterion. That means their sides are proportional. You can see here side AC in this triangle ACE corresponds to side AD here, okay? Likewise, side AE in this triangle and AB in this one correspond to each other. So we have AC over AD equals AE over AB. Then we have AC, which is 15, over AD, which is 12, equals AE, which is the diameter of the circle, and we should find it, over AB, which is 13. Then AE equals 15 times 13 over 12, which is equal to 65 over 4. This measure is the diameter of the circle, and we should find the radius. So radius equals 65 over 4 times 1/2, which is equal to 65 over 8, equal 8.125. Have a good time.